Thank you very much, Kathy, and good morning. It's a pleasure to be here to talk about the U.S. experience in food fortification. It's very awkward, again, to start with terminology, but it is essential, I think, for us to kind of get on the same page. Mandatory, voluntary, and discretionary. Strictly speaking, the FDA provisions for the grain fortification and enrichment are voluntary. They need not be used unless the manufacturer chooses to label their food as an enriched product, in which case it does become mandatory, and as Janet King just mentioned, there are standardized additions in the case of enrichment. Discretionary fortification is the situation in which the manufacturer adds other nutrients at their discretion. FDA has developed a fortification policy statement that's intended to guide manufacturers with these additions, but it's not really clear how many manufacturers actually follow the FDA fortification policy. In terms of a very quick overview, in the US, fortification has evolved and diverged. It certainly can be effective in addressing deficiencies, especially if they're relatively common. But there are now many unknowns about thoughts relative to fortifying to improve the diet and improve health, and there are growing questions about the practice of discretionary fortification. In terms of pragmatic issues, through regulatory experience, a number of touchstones have evolved, and these are themes you'll hear not only throughout my talk, but I'm sure throughout the morning. And those 4 or 5 touchstones are listed here. That's the need to start with a demonstrated public health problem, with something that fortification can address. Consider the unintended consequences of fortification. Determine the proper fortification vehicle and address any technical feasibility issues. Study the potential impact on age gender groups, and ideally carry out monitoring post-fortification. Janet has very nicely covered the historical role, and I won't spend time on that. I will jump in, though, in the 1970s and 80s and suggest that there was a beginning of a paradigm shift in terms of the way we thought about fortification, with the recognition that fortification is a balancing act. And this was underscored by experiences with iron, which I'll get to in a moment. At that time, FDA began actively articulating principles and guidelines for fortification. In the 1990s, we had the experience with folate, which gave us some new lessons. And at the same time, we began to recognize that nutrition can sell foods. There are very good marketing strategies now related to nutrition, and we see increased discretionary fortification. Now, backing up to the 40s, going through the 60s, with this whole concept of the enrichment of cereal grains, it was quite clear at that time that we weren't going to get people to go back to eating whole grains once they got a taste of refined grains. And at the same time, for some odd reason, in the 1940s and 50s, supplement use was really not very popular. I know it's hard to believe today, but supplement use was not popular. And so we landed on the concept of the fortification of staple foods. Through a collaboration between FDA and other public health groups, it was suggested that cereal grains would be a good vehicle. They're widely used, they're economical, many people can afford them, and they're a significant source of calories. They then tapped into FDA's role in providing food standards, and by the 1940s, end of the 1940s, we had standards of identity for enrichment. It took about 20 years for this paradigm shift in the way we were thinking about fortification to occur, and it was really brought to the forefront by the experience with iron enrichment. In 1974, the National Academy of Sciences recommended higher iron fortification, and they based this conclusion primarily on dietary intake data. FDA accordingly stepped up to the plate and revised its standards for enrichment to increase iron. Within a short period of time, there were objections from scientists and clinicians who were concerned about iron toxicity and about unsubstantiated clinical benefits relative to this higher level of iron. Through a series of back and forths for the next 3 years, it was debated, and finally in 1977, FDA agreed and they lowered the iron fortification standard. Now, this relatively traumatic experience for the agency ended up with the conclusion that fortification was to be based on clinical measures, not on dietary intake alone, and this was conducted through congressional testimony in 1982. At the same time all of this was happening in the 70s and 80s, again, manufacturers' interests in marketing food to improve diet and to improve health increased. At the same time, FDA began to express some concerns. The agency certainly supported the concept of fortification, but they were very worried about what they termed maintaining the natural diet. And this eventually culminated in the 1980s with the agencies outlining what it considered to be rational fortification in the FDA fortification policy. This is guidance. Strictly speaking, guidance is not enforceable, and even though it appears in the Code of Federal Regulations, the FDA fortification policy is not a regulation, rather it's guidance for manufacturers. It does hit on many of the themes we've sounded already, that there has to be a public health need. Interest is in correcting a demonstrated insufficiency. There needs to be technical feasibility. The food should be consumed in sufficient quantities so as to make a contribution. The nutrient is physiologically available. This goes back to Janet's example with zinc, and the nutrient is stable. It also groups concerns into unintended consequences with the interest in avoiding an imbalance and avoiding excessive intakes. Now, the folate experience launches us in a slightly different direction, and it began in the 1990s with a U.S. Public Health Service recommendation that in order to avoid the risk of neural tube defects, all women of childbearing age should consume 400 micrograms of folate a day, and current intakes at that time were nowhere near 400 micrograms. The first question out of the box, however, was, can women use a supplement? And the answer apparently was no, because the risk for neural tube defects often occurs at a time period before women know they're pregnant. So the powers that be turned to the folate enrichment standard, saying, let's add folate to this enrichment standard. And the first order of business was for the agency to demonstrate a public health need. Through 2 trials, observational studies, and some expert advisory panel inputs, they were able to demonstrate a causal relationship between folate intake and neural tube defects. But they did not rely on dietary intake data to do this. Rather, it was on the trials and the observational studies. They next turned to unintended consequences, and there were 2 main concerns here. One was the exposure for the non-target population, largely children and males. And in order to address this, the agency needed to specify how much total intake of folate you could have in a day and still consider it to be safe. Again, through the convening of a number of expert panels, the conclusion was arrived at that less than 1 milligram a day total could be considered safe for the US population. The second concern was that folate fortification could exacerbate vitamin B12 deficiency, and this was largely based on animal data. Having done that, they then turned to simulating the impact of folate fortification. They focused on whether the target groups would be getting folate in the correct amounts and would it push other groups too high. Obviously, the target was cereal grains because they were looking at expanding the standard for cereal grains. And through a series of somewhat clever analyses, they simulated adding 70 to 350 micrograms of folate per 100 gram of grain through a series of considerations related to the available food consumption data at the time, which told them the foods and the amount of foods people ate. And then they adjusted the folate content of these foods consumed in various ways and kept rerunning analyses till they had a full flight of information on potential exposures for a number of age-gendered groups. there were issues raised by these simulations. The first was that they discovered there was significant heterogeneity in folate intakes. Now, the U.S. diet is relatively diverse, so heterogeneity in intakes is not too surprising, but in the case of folate, it was a fourfold difference for age groups, and that's pretty notable. The projected fortifications also appeared to increase high intake persons, those at baseline who were already adequate, appeared to increase intakes more for them than for people at the lower end of the distribution. Now, I'm going to skip the sources of error for a moment and come back to the idea that this idea of different ends of the distribution responding differently to fortification means that you need to take into account the change in the distribution of intake, not just the change in the mean intake. And this is often overlooked. It's brought home by this slide, which is the projected daily folate intakes as a percent of the reference value. Over here you have the low end of the distribution. As you can see, their baseline is low. But with the 140 and the 340 micrograms per 100 gram increase, they barely get up to the 100% of the reference value. This group, the right end of the distribution, the high intake people already, when you begin to look at modeling 140 and 340, they're getting close to 300% of the recommended intake, of the average reference value. And this suggests, again, the importance of looking at the changes in the distribution, not just in the mean intake. Folate fortification began its implementation in 1996 when FDA finalized its rule indicating that they would use 140 micrograms per 100 grams as the basis for the enrichment standard. And this conclusion followed the comment period on the FDA proposed rule. It was seen as an accommodation between effectiveness and safety. However, many of the comments to FDA were based on dietary data. And at the time when it was promulgating the final rule, FDA expressed a lot of concerns about this. They were concerned that the dietary data were likely underestimates and suggested that really dietary intake data is much better for looking at patterns of change, not for projecting quantitative issues. It became effective, folate fortification, in 1998, and that gave us a chance to assess post-fortification what had happened. As you know, there was a reduction in the prevalence of neural tube defects, and there was also an increase in serum levels. As you can see, the average concentration shifted considerably to higher levels. Also, during the post-fortification assessment period, it was discovered that intakes were much higher than expected. Based on the dietary intake data used in the comments, the predicted addition due to fortification would have been about 100 micrograms per day. The actual addition after fortification, as it is currently, is approximately twice that, 200 micrograms per day. Now, the factors involved are ones that we've talked about already: underreporting, food intake, supplement use, probably considerable outdatedness in the tables of food composition. And then there's also the possibility that it is common practice for manufacturers to add more than the labeled amount. This both helps with compliance, should their product be tested, but it also helps with shelf life. So there's a lot of ways additional folate could have entered in. Assessment also gave us a chance to go back and take a look at the difference between estimating prevalence of inadequacy based on intake versus that based on clinical measures. Over here on the left with intake, with the various female age groups of interest, the prevalence of inadequacy ranges somewhere between 15 and 20% when you base it on intake. Same women 15 to 44 age group, when you take the clinical measures of serum folate and red blood cell folate, the prevalence of inadequacy virtually disappears. So again, this brings home the point of the importance of clinical measures. So in summary, the lessons from the U.S. fortification experience are A couple critical ones. Fortification may increase intakes of higher consumers to a greater extent than lower consumers. It's more difficult to move those people who are eating less food, eating less healthy, or have other challenges. Supplement use exacerbates this because they tend to be selected by people who already have great diets, and this brings home the point about focusing on changes in distributions. Modeling and simulation are key to ensuring that there's an adequate and safe approaches. Those were very valuable in creating the proposed rules for fortifying with folate. Again, a reiteration of the pitfalls in relying on dietary data alone. Certainly there are a lot of reasons to believe we're getting better at estimating the amounts of foods consumed, probing techniques. But I'd like to get up on my soapbox and say we have not paid enough attention to the resources for the tables of food composition. It's staggering how fast these kinds of things can change, and it's the other half of the equation. It's great if you know how much someone ate, but if you don't know what was in that, your estimates will still be off. So I'm making a cheer here for more resources for tables of food composition. If you can't really rely on dietary intake data, then you really do need valid biomarkers of nutritional status. And again, this is at least partially a resource problem. We need to explore this question considerably more. And then I'll add just a little personal thing, which recognizing that fortification can work, I do believe that in the US we deal with pockets of inadequacy as opposed to universal deficiencies. And as a result, I think that we might benefit from a two-prong approach when we think about trying to take care of these pockets of inadequacy. One is to consider modest fortification, kind of move all the boats up. But following that, there is the opportunity to target interventions for those that we know to be specifically at need. So combine fortification with some special targeted programs, and that offers the opportunity to potentially reduce unintended consequences of the kind that do concern people. Now, in my remaining few moments here, I'm going to freewheel on what might be the next U.S. experience in fortification, and some have suggested it might be vitamin D. Certainly, vitamin D receives an incredible amount of media attention, and probably not too much to your surprise, I would say that our previous experience points to the need to be cautious and careful. Fortification is a blunt instrument. It's untargeted and it's mass action. So there are a series, at least in my mind, of preliminary considerations that might be important before you begin to talk about vitamin D. A few of them are just listed here. We certainly need closure on the biochemical, the clinical cutoffs for population adequacy and inadequacy. We need better information on the dose-response relationships between intake and serum 25-hydroxy-D. And we need to be a little bit more sure that those who are at risk are really reachable by food fortification. And then relative to unintended consequences, we have to tease out those J-shaped risk curves that are starting to emerge relative to things such as all-cause mortality, and also note that those risk curves are different by subpopulation groups. Perhaps just as important, if not more importantly, in our preliminary considerations, we've got to document the public health need. If you base your considerations, your prevalence of inadequacy on serum concentrations, 17 to 20% of the US adults may be considered inadequate. If you use dietary intake estimates, 71% of US adults would be considered inadequate. This is a huge difference. Now, certainly some of this could be explained by sunlight, but in my opinion, not all of it can. And again, I'm going to get up on a soapbox and say that I think we need a more thorough explanation of our dietary estimates for vitamin D intake. Have we really captured all sources of intake? There's certainly unprecedented supplement use. In fact, there are stories of investigators who can't complete clinical trials because so many people are taking vitamin D, they can't find anyone to enroll who isn't taking vitamin D. Increasing discretionary fortification is certainly a factor. But I'd also like to argue that the presence of vitamin D in food is not clearly understood, particularly when it comes to 25-hydroxy-D from animal-derived foods. This is a very quick slide to suggest that we have a little bit of a starting point here. On the left, I know it's a little hard to read. This is intake, average intake for different age groups, and here is the average reference value. And as you can see, based on intake, very few of these groups on average are getting up to the 10 micrograms a day. Over here on the left is the prevalence you would see from serum relationships, again, same age groups. Here's the average reference value for serum 25D, and here it is for the 97th percentile. They're almost all above it. So there's this discrepancy. Some of it may be accounted for by sunlight. If you simply go by this, you really need a huge fortification effort. I wonder, though, next question is, are the intakes really that low? What about 25-hydroxy-D in foods? Animals metabolize vitamin D to its active form, 25D, and this form is present and stable in animal tissue. Importantly, it's approximately 5 times as potent as the parent vitamin D compound, and this has incredible contribution to intake estimates. But the real kicking point here is that this form is not included in the U.S. tables of food composition. We did have access to a limited USDA data set that allowed us to simulate intake changes when 25D in food was taken into account, and we were able to conclude that the intake estimates could increase, potentially providing another 15 to 30% of the average reference value, and this is shown here. In orange, current intake estimates based on current U.S. tables of food composition, here in orange. In the case of black, that's what the same intake estimate would be if you took into account the 25-hydroxy-D in food, again based on these simulations. So I would argue we don't even begin to have a handle on the amount of vitamin D that people are in fact consuming. And I guess I would also argue that we're not likely to have that handle very soon. We haven't initiated efforts to analyze for 25D content of food. Methodologies are still in development. We lack standard reference materials, and supplement use is changing by the day. So we've got a ways to go on that. And then my very last slide here, I will second freewheel on what might be the next U.S. experience in fortification, and some would suggest that it's a focus on this discretionary fortification. It certainly has increased, and its focus is on improving diet, improving health, and it's a very good marketing tool. I think the questions are, do these nutrient additions improve the U.S. diet and improve health? Are they benign, isolated practices? Or are they inappropriate or problematic? I think the parting question I would ask is really, should these practices be examined and perhaps thoughtfully addressed? And that might be our next U.S. fortification experience. So with that, thank you very much. I enjoyed pulling this together. It was a challenge and hope it's helpful.
Thank you.